Hello all, welcome to the new video of signals and systems. So in this video we'll see a question related to digital communication which had appeared in DRDO examination. So there is this topic called as random process and probability and probability density function. So from this topic there will be some questions asked even in GATE examination. So keeping that in mind, I thought I'll just solve a question related to this so that people who are studying for GATE PC 2017 will get to know what kind of questions may appear from digital communication, okay, especially from this topic. So you need to study what is probability. I think those who have done engineering are familiar with this topic, probability. And then there is something called as probability density function, and another, there is something called as cumulative distribution function. So you need to know all that things. And there is white noise and different types of noise which I have covered in other videos. So you need to study this topic if you're aiming for a top ranking GATE. So coming to the question is, consider a random variable capital X defined by probability density function as shown here. So the probability density function is a constant k from x is equal to 2 to x is equal to 4, okay, and it is 0 elsewhere. So if you just plot f of x, it is something like this, okay, between 2 to 4 it is some constant k, this is x, okay, and it is 0 elsewhere. So we have been given this probability density function. We need to find what is the value of this k, okay, and then we need to find cumulative distribution function f of x, and then probability of x less than equal to 3.5, okay. So once we solve this, we'll get a fair idea as what all these formulas are, etc. Okay. So coming to the first question of finding k, we know that CA. So f of x is a PDF, okay, probability density function. So by definition, the integral, the area under this probability density function should be equal to 1, okay. So using this formula, we need to calculate k, which is fairly simple, okay. So since it is 0 elsewhere, we just need to find out what is the area from 2 to 4, okay. So using this, we get limit from 2 to 4 f of x into dx, okay, which will be equal to 2 to 4. Between these limits, the probability density function is constant k. So this will be k, and this is the integral of dx is x 2 to 4, okay. So that will be 2k, okay. This should be equal to 1 because the area under the PDF is equal to 1. So our k value is 1 by 2. So this is we have found out what is k. Now next we need to find out what is the cumulative distribution function capital F of x base of x, okay. So let's do that now. So to find out cumulative distribution function f of x, there is another identity, that is cumulative distribution function is, by definition, it is minus integral of PDF from the limits minus infinity to this value of x. Okay, so we know what is f of PDF, so just we need to place here. This will be equal to k times dx. This k is from 2 to 4. Okay, so we need to change this limit accordingly. So by definition, the cumulative distribution function is integral of PDF from minus infinity to this x. Okay, so this x is unknown as of now, so we are aware about the lower limit, that is we know that the PDF doesn't exist before x is less than 2. Okay, that is f of x, 1 minute, this is 0 for x less than equal to 2, so this will become 2 to x k dx. Okay, so this will be equal to 1 by 2 into x minus 2. So this is the value of cumulative distribution function. And next part is probability of x less than equal to 3.5. So let's find out this. So next we need to find out the probability of capital X less than equal to 3.5 using the PDF which was given earlier. Okay, so there is one interesting identity or interesting definition, okay, which many of us don't know. That is, cumulative distribution function f of x, this capital F of x base to capital X, is nothing but this is very similar to probability of capital X less than equal to small x. Okay, so if in this question they have asked probability of capital X less than equal to 3.5, so it's nothing but they have asked to calculate what is the value of cumulative distribution function for this f of 3.5. So earlier we found out that for this question the cumulative distribution function is half times x minus 2. Okay, so substituting the value of x here, we get 3.5 minus 2. Okay, so that is 1.5 by 2, which is equal to 0.75. so this is the value of probability of x less than equal to 3.5. so just remember this identity, which will be useful for 1 mark questions which will appear in GATE related to random processes and all the probability related questions. This is called as cumulative distribution function. Okay, and we can also calculate this probability, that is probability of x less than equal to 3.5 will be equal to minus infinity to x. In our case this is 3.5 will be equal to, this is probability density function. Okay, so we know that the probability, we know the value of k also, so from this will become minus, we will calculate it from 2 to 3.5, since from minus infinity to less than x less than 2, if x is equal to 2, till here the value is 0. Okay, later it is 1 by 2, so that will become 1 by 2 times x, so this will be 1 by 2 into this is dx, right? So this will become equal to x limit from 2 to 3.5, the same as this. So these are the two different methods which you can follow to calculate this. probability. Okay, so this is a fairly simple 1 mark question. I just wanted you to not ignore this topic because many of you will usually ignore the digital communication topic for any competitive examination, but it is fairly simple. You just need to understand three important things. Okay, one is probability, and read about PDF and then CDF, and also on white noise, Gaussian noise, etc. Okay, so thanks for watching, guys. Kindly subscribe and also visit our site gatec.org. You can, if you want us to make any particular videos, you can paste in the comment section. Thank you.